Hi, everyone. So my name is Matt Herman. I'm with WSP. I wanted to go back a few years. If you remember digital twins, I remember there was a lot of talk about digital twins, what they were going to do, how they going to transform the world, and why we all needed them. And as technologists, I'm sure you guys learned a bunch, and then we haven't heard too much about them of late, right? Well, I'm sure you can imagine that the hype often doesn't match the reality when we move into implementation. I want to talk just a little bit about that from our perspective. WSP touches just about every aspect of the built environment, and that includes projects that last 20, 30, 40 years. And as a result, we couldn't just abandon the digital twin hype because it got written into contracts and we had to deliver. So I want to talk just a little bit about some lessons learned, and also as fellow technologists, people who believe in innovation, I've got some asks. As you know, you've probably seen diagrams like this before. There's the idea that there is some type of twin prototype that exists primarily in the form of geometry. Where you add value to that geometry is where you can connect it to some type of predictive simulation. And there's a wide variety of tools that are out there. They're always difficult to interconnect to the geometry, but when you can get them to work, it can be quite useful as a predictive way to think about the future. And then the dream is that at some point, that physical asset that ultimately gets built is connected to the twin model, and that there's some type of magic that happens behind the scene to add value along the way. And it's real, right? When it happens, it is real. But we are definitely in the valley of the hype cycle here with the digital twin. And so, yeah, there's some lessons learned along the way as we come down from the promise into the reality. I'm sure all of you were excited to meet your digital twin at some point, but alas, I'm still looking. I haven't quite found him. But there's hope. Some lessons learned. So obviously, initially, you've got the shiny object syndrome, right? It's a great idea. It's so enticing. We can do this. There's bits and pieces of it spread across the industry. All we have to do is link them together. But ultimately, the vision doesn't turn into reality. And so that's what causes that big dip. Now, as I mentioned, there are institutions and organizations that truly benefit from the kind of long-term thinking that a digital twin can provide. If you were to think, I'm just going to ask you guys, who do you think is still pursuing digital twins? Any guess? We'll go. Factories, right? Because they have a lot of process equipment. That equipment is highly modeled within a digital environment, much like an airplane or a ship. Any other institutions? Infrastructure, right? It's really the infrastructure. Federal government in particular right now is big, and that's where we're seeing these multi-year contractual obligations to deliver a digital twin play out. Infrastructure projects, bridges, highways, just to name a few. But along that way, that kind of long-term thinking, which can be difficult in a political cycle, has resulted in slowly but surely breaking down some of the roadblocks. One of the things that we see, and this is very true at municipalities, is just gather all the data. We'll figure it out later, right? The data has value. That's true, but if it takes an exorbitant amount of time to get the data into a format that's useful to drive decisions, then it's not valuable, right? There is some hope that AI can help solve some of these problems by allowing data sets to be blended or trended in a way that makes them, if not more accurate, at least useful. Key stakeholders not engaged. So this comes down to, though your contract for a long-term project, a mega project, may span multiple years, 10 years, et cetera. The political realities of some of the institutions we all work with, whether it's higher ed campuses or municipalities or the federal government, tend to run on 2 to 4 year cycles, which can make it really difficult and you lose stakeholder engagement. which requires an underlying master plan, basically a set of policies and principles that everyone has agreed to that are in place, linked to your contract, in order to actually get the consistency across the duration of the project as it relates to the implementation of the digital twin. The role of the vendors is often unclear, and this becomes problematic. I'm sure we've all worked with the big vendors, Bentley, Autodesk, et cetera. They're all great. They're all amazing tools, but a municipality sometimes has trouble making decisions about going with one proprietary package versus another, not to mention the added cost of the data storage associated with all this information. So that can create a lack of clarity in what type of vendor or partner you have. For instance, if you buy a software, the software itself is just a tool. You have to have staff, hardware, storage capacity in order to take that software and make it useful across the duration of the project. And if you're talking about an asset management digital twin, well into the future. Lastly, the builder and the building industry is not ready for digital. A lot of this comes down to the size of the enterprises that many of us have to work with on a day-to-day basis. WSP is 70,000 people. We can buy digital twin infrastructure. We work with federal governments. They can buy digital twin infrastructure. A local small business that has to then work within that digital twin process can oftentimes not afford the infrastructure required, the training required, and therefore it often requires a mentorship protege model in order to effectively implement across all the various stakeholders in the process. And then you multiply that over various economic cycles, boom, bust, hold on projects. It gets pretty risky for the small businesses to take this on, and inevitably you see the pushback. So where are we seeing it? As I mentioned before, we are definitely seeing it in infrastructure projects. Why? Because these are long-term stakeholders. And speaking of other hype cycles, does anyone remember the automated vehicles? They're not gone yet, but they are very much in this same hype cycle. So as we begin to plan out these large infrastructure projects, beginning to implement and transfer both the digital twin to automated vehicles, as well as the necessary infrastructure, meaning the sensors, so that they can increase safety, becomes part of the thinking process. The other component to infrastructure and the digital twin is resiliency. We are seeing infrastructure significantly damaged by increased intensity in storms and other climatic events. That infrastructure is expensive and difficult to replace. And so embedded within the digital twins that we are seeing emerge at the municipal, institutional, and federal level are resiliency strategies and planning that ties it into flood maps, fire, wildfires, disaster recovery, even into things like crowd management for civil unrest. So tying these things together is still incredibly cumbersome, but there is hope. So this is an example of beginning to plan through and think about the use of automated vehicles, autonomous vehicles within the infrastructure and showing examples of how that plays out. And of course, it ties into taxpayer dollars. These are some early prototypes. We have other examples of trying to get the asset management of long-term assets like bridges into a true digital twin, which is harder than you would think. I saw some familiar softwares that are enabling some of this up on some of the earlier presentations. So glad to see that there's funding and investment going into these tools, because when they do come together, they can be quite useful. Things that we've seen that are roadblocks, though, is inconsistency in the process. So basically the master plan that I was talking about that underlies the digital twin. One of the things that we always say is digital twin is not a thing, it's a process. So making sure that that language, the ISO standards and other standards that are referenced are consistent across different pieces of the built environment. Another component is the way that we access some of these tools. Subscriptions can be problematic because they end. That can be a real problem for us or a challenge for a municipality who may see it as an advantage during the construction phase, but ultimately not being able to transition into the asset management promise of a digital twin because a subscription ends or a company is bought, goes out of business. These are other risks that, in particular, public agencies try to avoid. So back to the built environment and kind of buildings and what we deal with on a day-to-day. I think this is kind of some of the ask that I'm here. I think fundamentally, most of the people in this room understand the infrastructure, the data, the opportunity, and the capacity for a digital twin to truly benefit our industry. It starts with the data, no doubt, but the data needs to be consistent, it needs to be cleaned, and ultimately it needs to be publicly available. Linking it to geometry, not hard. We've done it before. There's standards in place for that at the building scale. But what we often find, of course, is that right now we're still submitting PDFs or even worse, paper for most of our building permits. So getting the digital component, the BIM model, as an acceptable, permittable document is something that would encourage us all to do when we are engaged with our various public agencies and professional groups to lobby for that. It's critical as the next phase of the evolution of our industry. Getting the geospatial data linked up with the data, so the data which is related to human activities becomes pretty easy, but again, important to do. A lot of inconsistency in how that's being done from municipality to municipality, if they're even doing it. And lastly, I think this is the area of optimism for us. An area of research is taking the idea that why we're doing all of this is for humans. So having some type of human-centered simulation that allows us to really think about the moment-by-moment behavior patterns of humans as we live, work, and play in our buildings, in our cities, in the built environment, and beginning to think about the carbon dioxide emissions that come out of that living, working, and playing. And then lastly, making sure that all this is accessible so that we can harness that data for the energy transition and carbon dioxide emissions management. We've been working with Ellis Cities and another group called Run With It Analytics to test some of these ideas out in real world projects across a wide range of different scenarios. As WSP is primarily focused on the carbon dioxide emissions associated with these behaviors, we tend to look for ways to streamline information and decision-making around that single variable. And that is sometimes challenging. I'm going to talk about that in just a little bit because energy, specifically electricity, is particularly problematic in the way that we communicate and talk about it. So this is our electric grid in regions. I think you've probably seen this or are vaguely aware of it. I find that even when I talk to electrical engineers and I say the word grid, they think it includes source providers. On average, it doesn't. These source providers are becoming increasingly important as our clients ask us, designers, engineers, builders, to deliver net zero buildings because their clients, their shareholders, stakeholders, are asking them to do it because it's essential to unlock investment capital through ESG criteria. If you have ever tried to do ESG documentation, you are immensely aware of the lack of transparency, the lack of methodology, and the disparate data that you are relying on to record and make those calculations and reportings. It's getting better, but it's incredibly time consuming, and it does ultimately tie into the built environment that we are all responsible for designing. Right now, this vaguely represents the renewable assets that the United States has and the transmission links that allows those renewable assets to be transferred across the grid. This is not enough. Right now, what we're seeing is early adopters, primarily large corporations, and some institutional clients make large-scale investments through renewable energy purchases, both physical and virtual. This is great, but it's not going to get us there. We need to radically and drastically expand the renewable energy infrastructure associated with that to support the built environment. And our electrical grid, which is the transmission lines that allow this to all happen, cannot accept at this time the full integration of our fleet vehicles into all electric systems. Nor can it accept a sudden shift from natural gas for heating in northern climates into all electric heating and cooling. Don't give up. Can be done, but it's going to take a lot of data, and a digital twin is one of the enabling technologies to help manage that. So we were asked to decarbonize hundreds of buildings within these 7 cities. It's a great opportunity, incredibly exciting, and if your metric for success is carbon, this is like winning the commission to design the Taj Mahal. How do we do it? What do we need to do? And this is not a strategy. This is like, what are we going to buy? Right? What are we talking? We're talking about investments. How much is it going to cost, and what are we going to buy, and how soon can we buy it? And what do we get for that? How do we work out the economics for it? So as we dug into that, sorry, one second. What we realized is that the Internet of Things and smart buildings and smart grids all have to quickly become real in order to manage that electric demand and the inevitable purchase of a limited supply of renewable electricity. When we think about net zero, this is what we think about. This is a representation of the infrastructure required to deliver net zero for hundreds of buildings in 7 different cities. It requires upgrades to existing assets. It requires smart building technologies for load demand management. It requires real-time data for electricity management, and all of that comes together into a digital twin. So to conclude, if I was to think about what a digital twin needs to evolve in and the enabling technologies around it, working out our shared data delivery systems across various municipalities is critical. As we collect more energy data in order to assess the load and demand created by converting our building stock and vehicle stock into all electric, that information needs to be shared seamlessly and smoothly. And it has to be shared across those grid regions that you saw. Our urban building information models and energy data needs to be shared seamlessly, tagged to the right information, and that will require the use of the BIM models being provided as the permit documents and moving away from 2-dimensional PDFs. So it's not a or, it's an and in that case. This data is essential for smart grid management and microgrids, which is real-time data transfer, so that the incremental load and demand on our electric grid can be managed during the transition period from fossil fuels to electricity, and specifically renewable electricity, which will become, and it already is, a limited resource. And as you know, supply and demand usually drives costs. So we can't let cost become a barrier to these things. Investments need to continue to flow, needs to be seamless and transparent. It needs to be easy for the consumer to make these decisions so that, yes, a digital twin is an enabling technology, but it is not the end result. So we're very much still on that journey. The digital twin is a process, not a product. Therefore, there's a number of products that need to seamlessly integrate into municipally acceptable, publicly available digital twin background information. The smart grid transition requires shared data of both the end user as well as the grid, electric supply and demand. And ultimately, renewable energy is a limited resource that needs to be managed at all scales: state, city, grid regions, national, and international. And that does require a common data platform that designers, contractors, and building owners can access the data in real time in order to make informed decisions on their energy purchase.